Good morning, good afternoon, good evening, everyone. We are all over the world today. I am so happy to have speakers from the US, we have speakers from China, we have market leaders like Khatod. This is going to be a fantastic evening, afternoon, and morning. It's 3 p.m. We are exactly on time once again. So, Sana, are you ready?
Yes, ready.
Let's go.
Let's do it.
We talk about polymer optics. The advantages of special plastics compared to glass are well known in optics. Components are much lighter, lower cost, and multiple optical and mechanical features can be combined into a single part. But as polymer optics get more complex, critical production knowledge is shifting towards materials. Especially in automotive and medical, parts need to be tailor-made to exactly fit the application. You can create high-volume, cost-effective products that are usually impossible to copy. We'll be discussing technology business opportunities on Monday, July 6 at 3 p.m. Central European Time at the EPIC Online Technology Meeting on Polymer Optics. Let's explore real-world opportunities. So let's explore real-world opportunities together. And there is no better way of doing that than the epic style. Just remember, this is not a webinar, but we are live in YouTube. We are here to find business opportunities. I think half of you know, half of you, there is 50% of the room that you don't know. And during these 2.5 hours, we're going to solve this. And after this, I'm going to make introductions for everyone. And you're going to do business the epic style. This is going to be the 34th Epic Online Technology Meeting. Only 5 to go, Sana. We are reaching almost the end. We have energies. Definitely we have energies to go all the way till the end. The last 4 meetings are going to be on Wednesday with a specialty optical fiber. Companies like Valeo or Siemens are going to be there. Then we have a meeting on Friday on precision horticulture and agriculture. We just signed an agreement with the AIPH, the International Association of Horticultures, to find the end users for this meeting. We have a meeting on microscopy next week on Monday, and we finish on Wednesday, and we all go on holidays. We finish with ADAS and autonomous driving. I would like to say that when we started this, the COVID-19 was the only topic of discussion, and we said, okay, let's make something crazy. And we decided to organize 40 meetings in 2.5 months. And the response of the industry has been so overwhelming that every day I go so happy to sleep, knowing that now we almost have 600 companies supporting EPIC. Many of you have asked what we can do to support the association. The best thing that you can do is to send us the application form, because with your support, we continue doing these amazing things. I would like to also thank the EPIC staff. This is a strong team that is working every day from Monday to Sunday, from early morning to late evening, finding ways of connecting the companies. And just to remind you that at EPIC we do a few things. We organize events, but not because we are an event organizer, but because we want to find suppliers, customers, and partners to every company that is a member of EPIC. Actually, half of our staff has PhDs, and they want to understand the technology of every member. We also find ways of connecting companies, and the members of EPIC in the room today know very well that. We also find a way of raising capital, but we never get a percentage of that. We just connect the investors with the companies. We had the biggest website to find a job in photonics, jobsinphotonics.com, and we have a lot of market reports, 17,000 market reports that we have bought from Thematis, from Joule, from Statistics Unlimited, from Lightco. The whole idea is to give you these market reports for free. So you have now, everybody who is a member have access to a long list of market reports. That's all I have to say about EPIC, because today I want to talk about one of my passions. I want to talk about plastic. I want to talk about polymer optics. And first of all, I would like to thank the support and the sponsorship of Obducat. This meeting would have not been possible without the support of Obducat, all the way from south of Sweden. I went to visit them. I was amazed by their tools and equipment support manufacturing for nanoimprint lithography and other processes for patterning structures. Obducat is a great company. I'm really happy to have your equipment and tools sponsoring the event today. Almost as happy I am as having Sana as the co-chair today. Sana, what's in the menu in an event on polymer optics?
This is very interesting meeting, particularly interesting with the list of the people that are present here that know each other actually. And we have people who have the time now 6 a.m. and the others have it 10 p.m. in the afternoon from Japan to the US. really amazing meeting. Please, I don't like to see the list of speakers like this. Can we go to this kind of presentation of the speakers? You see here, we look at the polymer optic manufacturers, and we have the some of the most important companies in the field, CDA, SUS Micro Optics, EVG Group, and we have also, of course, the integrators on one side, like Inkron Photonics and some of the pilot line, European pilot line, and we have the end users. Later we have joining us from Volvo cars, Huawei, and Wave Optics. And we look at the most important ingredients for polymer optics: the master side, the printing side, and the material side. So we have the companies like DNP, and we have DELO and SABIC for the material side. We look at the whole supply chain, the coating, the R&D, also the metrology side, and we even have the market intelligence side to look at. And we have company that make them all. Of course, the vertically integrated optical instrument, we have Jenoptik today also in the room. So this is how I would like to present. We're going to be looking at all of them. Jose, why some of EPIC members are missing from this?
Very good point. Many of you keep asking, my logo was not in your supply chain for Polymer Optics. This slide only represents the companies who have registered for the meeting. Sana and I never forget any of our 585 members of EPIC. And as you can see, we have the Day Nippon Printing logo almost everywhere in the slide because they are our one-stop shop for Polymer Optics. Thank you so much for being a member of EPIC DMP. I would like also to say that we are broadcasting this meeting in YouTube. So now I would like to say hello to the YouTubers. Hello. If you want to contact any of the participants today, speakers, non-speakers, any of the participants today, all you have to do is send me an email, jose.pozo@epic-asoc.com, and I will make an introduction because our job is to make sure you do business. This is, of course, also valid for the people in the Zoom room. If you want to get in touch with each other, of course, you can use the private chat in the Zoom tool, but I'm also happy to make an introduction after the meeting so you can pursue a potential collaboration. When it comes to, Sana, when it comes to silicon, I go to Silicon Valley. When it comes to optical instruments, I go to Jena. When it comes to automotive, I go to Munich. When it comes to polymer optics, I go to the Silicon Valley of polymer optics in Europe. And that's in Aachen. That's in Aachen, and that's one of my favorite cities in Europe, Aachen. I'm so happy to have Cornelia representing not only Fraunhofer IPT, but the whole area of manufacturing polymer optics. Cornelia, thank you so much for joining today. It means a lot for us that you are our opening speaker and mostly to tell us the epic question. What can the rest of us do for you? And what can your beautiful ecosystem in your beautiful Aachen city do for us? The floor and the attention of everyone goes to Aachen, goes to Cornelia, goes to Fraunhofer IPT. The floor is yours.
Thank you, Jose. So thank you for the kind introduction. First of all, I actually jumped in this meeting quite quickly, and for the ones who perhaps know Tobias Müller from Fraunhofer IPT, I'm the one after him, so I'm the next Tobi Müller. So the next Tobi Müller is not Tobi Müller, but Cornelia Rojacher, and I'm the head of business unit in Aachen at Fraunhofer IPT, and I will go to
Fantastic. While you put the slides up, first of all, I would like to say you have very big shoes to fill in for Tobias Müller, but I'm never going to call you the new Tobias. I'm going to call Tobias the old Cornelia. I think that's much better. So Tobias Müller is on holiday, so is Christoph. Cornelia, thank you very much for stepping up. All you have to do is at the bottom of the Zoom window, go to share screen, the green arrow up.
There I am, but...
And the whole supply chain is here waiting for you. We had the materials from SABIC, we had the coatings from Senija, we have Inkron with a fantastic coating solution for filters. Let's help you. Go to presentation mode.
Presentation.
Yes.
Can you?
Yeah, we can see your screen. You go to slide mode.
Okay, I think it's on the wrong.
It's good. It's good. Yeah, you may be sharing the wrong screen. The best thing to do is to unplug the secondary screen. That works always.
Okay, let's do this.
It's the manual solution.
Okay, so
now we're going.
yeah,
thank you very much. The floor is yours.
Okay,
We have you muted by accident,
Yes.
please. Okay.
Now I'm back again. Okay, so yes. Also from my side, hello from Aachen. I think it's a beautiful day and I'm very happy to be joining you. So today I'm going to talk about polymer optics, what we do in Fraunhofer Institute for Production Technology in Aachen. I think, so first of all, a couple of words to Fraunhofer. We're founded in the 40s and there are more than 70 institutes all over Germany with more than 26,000 employees. Besides the scientists, we also have a lot of students, so we keep on running. We're a really young and motivated community. And for our quarters in Aachen, we're about 460 even now employees. And as I said before, a lot of students, so half of them are permanently there. So I guess we're known in EPIC, especially for glass optics. Precision glass molding, for example, is one of our, let's say qualities or competencies where we can manufacture highly precise glass optics with microstructures, free forms, wafer level molding is what we're heading to do. And the great advantage of this production type, where I'm actually coming from, is the more complex it gets, the more worth it to go with this. So as I already said, we have freeform optic microstructures, for example, for diffractive optics, but also for infrared optics, like microstructuring the surface of optics to enable a lower degree of reflection is what we're currently working on. Spherical optics. There are a lot of, let's say, different markets that we could go on with this and that we're addressing and trying to realize new functions by this. But as I say, as you already said, we're not here to talk about glass, but we're here to talk about plastics. So polymer optics is actually what we also do in Aachen. And we have the whole process chain. So based on the, let's start with the mold making. So the tool making, we have the ultra precision diamond turning and grinding machines to manufacture the molds for the injection compression molding. And here we can see a couple of examples of what we the last time or in the last periods actually manufactured. And what I really want to talk about, or what I really want to figure or highlight at this point, is our microstructuring. So not only for glass, but also for the polymers, we're able to manufacture the molding tools and manufacture or replicate the optics in glass, but also in polymers. And this is what you can, for example, see in the middle picture. We just do light guides. We're also doing, for example, microstructures like Fresnel lenses at the moment. So let's say microstructuring is, I think, one of the top themes that are coming up, and we're in both in glass, but also in polymers, very keen to go deeper in these topics and to develop more of these kind of functionalities. Something that is also special, I think, in Aachen is that the whole process chain that I exampled out already is what can we do for you is we can do glass optics, polymer optics. We're assembling the optics to a system. And also we do evaluations. Based on this, what is special for Fraunhofer IPT is there are a lot of spin-off, a lot of good ideas that turned out to make their own way. And these are their examples based on the topic of optics. So we have Engeneric, who are working with the glass optic replication, Inolite as well, Sonics, who do the molds, Ixemtech, who is working with the mounting. And so I think that is the community that we have here in Aachen is very special. So we're going to the deep need of what is necessary for the industry as well as the science. And therefore, I think it's already the last slide, and I hope I'm still in time. Perfect. So the next year, we're starting ARCOP, which is the Aachen Center of Optics Production. And with this, we're focusing on 5 themes, or in 5 topics, which are glass and polymer optics, the 2 of them. Then we're going to, then we're going to the metrology to really go deep in those special meetings. We're assembling, and we are the digitalization, who is networking all of these. So the Aachen Center of Optics Production is going to be a network from the scientists of Fraunhofer IPT and the community, the optics community, who will participate as partners and tell us about their needs and their interest in which topics we should direct to. So, yes.
Thank you very much, Cornelia. Fantastic and right on time. I like that. You have to come more often to the EPIC meetings. I really love this change in the staff of Fraunhofer IPT. Hey, Tobias, good to see you. I know you're on holidays. This is an EPIC meeting, so it is all about collaboration. So the most important thing here is to identify routes to collaborate. I always present Aachen as the capital of polymer optics. You organize every year the polymer days that brings everybody together. I was going to be there, but obviously I heard there is a virus going around, so we couldn't do it. But today we have a good representation of the supply chain, and you presented companies like Inolite, like Engeneric, like Ixemtech, like Vadient, like Sonex, like Polyscale. I don't want to forget anyone. Can you tell us a couple of challenges in the supply chain that these companies perhaps can add value to your current ecosystem? I have you muted. I want to hear you. Yes.
Yeah, now I think of that. Yes. So I think one of the big challenges is actually the digitalization, which we're addressing, but we still like to work together to see what need is in the industry. What we're I think would, like, for example, in glass optics, we're still working on manufacturing molds with microstructures, but with materials that are quite hard to manufacture or to work on. So these are, for example, points.
So for me, it is clear that when I see your ecosystem is very strong in molds, because you have Sonex, which by the way, they are fantastic. Hi, Benjamin, if he's hearing us. You have companies like Polyscale in the roll-to-roll manufacturing, but when it comes to the material side, of course, there is perhaps some room for collaboration. Companies like SABIC, like DELO could perhaps add value to you.
Yes, most definitely. So.
Okay, so Bernd is smiling from SABIC. I think there's obviously some room for cooperation there. I want to ask something about the market, because now you're going to be traveling around the world, and I'm going to see you every 2 weeks, like I used to see Tobias. What are, in your opinion, the biggest application fields, the biggest markets in which you're going to put optics from everywhere, including from Khatod?
So the biggest markets, I think there is actually, like to say there's the biggest market is, I'd not go there. But I say that the diversity is quite the strength of it. So because with the mixture of polymers and glass optics for Fraunhofer IPT, we can we can pretty much direct it to all the important based on, for example, laser optics with the glass, and then we go down to automotive constructions with polymers. So I think this is actually the strength.
The automotive Volvo is gonna come in 1 hour. They have to be here, but we had a problem. But they're gonna come in an hour to tell us exactly what they need. But in the meantime, I'm gonna go to what I think is gonna be the big market. I have a company called Wave Optics here. Arseni, how are you doing?
Hi, Foss. I'm good, thank you.
Thank you very much for joining. We had a meeting on lithography last Friday, and now here we are talking about polymer optics. And I remember last Friday you shared a couple of challenges with the community. I want to start the meeting with that. Can you give us a couple of challenges on the polymer?
I mean, in terms of polymers, we're already using them in nano-imprinting, obviously. And I would say that the optical quality of those polymers used in nano-imprinting is a big topic for us, because we need them to be very homogeneous, both in terms of optical properties like refractive index, absorption, also thickness. So that's the challenge we're having right now. But in general, I guess in the whole AR community, potentially there is a desire also to do plastic waveguides made out of plastics. But for this, we need to go into really high refractive indices. And that's another challenge for the plastic optics, let's say.
What is high?
I mean, right now, our desire is above 2.0 for the devices which we are doing right now, but they're based on glass plus nano-imprint resins.
You know, the fun thing of the online meetings is that I can do magic. I have your slide from last Friday in which you told us the challenges. Could you revisit that slide? Could you tell us the challenges that you have for this community?
Yeah, absolutely. So basically what you see at the top was written specifically for the nano-imprint resins. And you can see that we desire them to be really high refractive index above 2.0, very homogeneous, confirmed optical quality of those resins. But I mean, I guess if we're talking more specifically also about plastic waveguides, we do want to do curved plastic lenses, and we probably would be willing to start at some lower specs, maybe starting from 1.7 refractive index, which is, I guess, is already a challenge for plastics.
1.7 refractive index a challenge? Who can provide 1.7 refractive index polymers? Yes, I'm gonna talk to DELO. DELO, let's do business. Patrick. I go to Patrick and then I go to Bernd. So go to DELO and then go to SABIC. And I get no commission. Christian, you see how I work at Epic? No commission for me. Patrick, what can you do?
Just received this. Pretty sure, Arseni, you know that. And it was a huge success story last year. This year on the Photonics West, and it's on the show now here on the flyer. So it shows that polymer optics is really something that is going into big business now. Definitely we can supply 1.7. I guess Jukka will also tell you that he can supply more in his talk. It always comes to the question of the full package. So you need the process, you need the stability, you need the reliability, you need other factors like transmission, dispersion. So how well can you match that, and how well can you match the polymer to the supporting glass that you have below that? That's all questions you have to answer, and we have a team that can work on that and can supply solutions to that.
Patrick, sorry, let me just clarify. In terms of nano-imprinting, I guess we indeed discussed on Friday as well. But what I actually meant are some plastics which are suitable for injection molding, not nano-imprinting, which is a bit different technology.
Bernd, do you want to add something to this?
Absolutely. Yes. So we cannot provide the 1.7 RI, but 1.65 in the near IR. And we are providing thermoplastic solutions. So injection molding, injection compression molding, or even hot embossing is possible. And we are in contact with Fraunhofer IPT, with CDA, with NILT on that one, and we have a lot of findings already, so it's possible to use our materials. And I will introduce the XTEM, a reflowable thermoplastic resin later on today.
Yes, you will, and I'm so looking forward to that, and I'm going to go to Finland. Jukka, you have something to add to this as well?
Well, we don't have those plastics, but we have the nano imprinting resins, like the coatings. So as Patrick mentioned, from DELO side, we indeed have something more than 1.7, 1.8, and over 1.9. And I agree that the higher you go, the more tough it gets with many ways.
Inkron is a great company. So happy to have you here. Anybody else would like to help our friend Arseny from Wave Optics with a polymer that can be used for injection molding on more than 1.7 refractive index? I think we already found you 3 potential partners, but we continue. This is going to be a great meeting. It started great. Thank you very much, Cornelia. And we go to Munich. We go to Munich to talk to DELO. We go to Munich to talk to DELO on how we can help the whole community can help DELO being even greater in the field of adhesives, in the field of polymer, and in the field of assembly using your fantastic adhesives. The floor and the attention of everyone goes to Munich, goes to Patrick. The floor is yours.
Thank you, Jose. Thank you again for putting up this great meeting today. And Arseny, maybe I can convince you that we might have a solution for you, not only for nano imprint, but also for larger lenses. So DELO is a German company based close to Munich with around 800 people here and offices and engineers all over the world to support you wherever you are. So if you have your R&D in the US or in Asia and production on the other side of the globe, we have people there that can help you set up the process, do the design, give you feedback on our solutions. So what we're talking about is not really injection molding, but something in between. So a kind of stamp process where you apply your material, a polymer to a substrate, then do an imprint with a working stamp, a UV cure, or a heat cure, demold, and you do everything on a wafer level, do dicing, and get individual optics out of that. This could be nano up to more or less macro lenses. And that's the very interesting part of this field, that you actually stretch many orders of magnitude in layers thickness as well as in imprinted area. So going from really small structures, diffractive optical elements for face recognition applications, up to like really large optics for automotive headlamps. Everything in between could be manufactured by this kind of technology. And we have solutions for that. We have various products in the market out there for macro optics, for micro optics, for nano optics. And we can also achieve a huge range or offer a huge range of refractive indexes for that. We tune the mechanical, the thermomechanical parameters, reflow stability, thermal stability to the needs of the application. And one of the applications, or one of the fields that is getting more and more interesting for that is automotive. Optics for headlamps, for LiDAR sensors, in-cabin sensing, augmented reality applications in their cameras. Everything you can think of where you need an optic, you could actually use one of our products to make the optic. And we can test that. We can do all the testing for LiDAR, laser-induced damage threshold testing, long-term automotive reliability testing, and our materials can survive that. But let's talk about more than just transparent, simple optics, what most people would think of. What about using this technology to manufacture full sensor assemblies? So you take your PCB with your sensor die on top of it, and then everything else you could actually make out of such polymers, light or heat curable polymers. So you make black walls, you make encapsulations, you make diffusers. Let's take one example, because time only permits one. Let's look at a diffuser. So use a liquid material to make a solid diffuser in any kind of shape and thickness. We could offer materials for that, which have a defined diffusive pattern in a defined layer thickness, which is also temperature stable. So you see here on the left, the transmission after 3 times reflow, it's perfectly stable, and it will maintain its diffusive properties over lifetime and over reflow. So this would be very new options you have in manufacturing full packages for your sensors, optics, and all the surroundings of the sensors. So with that, DELO would like to achieve goals together with you. Be innovative, have new ideas, and use materials to actually enable innovation. Thank you, Jose.
Thank you so much, Patrick, for this very inspiring talk. And let me ask you now the epic question, right? What can you do for the people that are present here and the others following us on YouTube? And what can they do for you? What challenges can you offer them?
I mean, we have quite a vast portfolio of optical materials, going from infrared transparent black materials with infrared transparency, scattering profiles, transparent large optics. So challenge us, give us the smallest package you want to achieve, the smallest layer thicknesses of black walls with mechanical stability, and we would be glad to discuss that with you.
And what kind of collaborations can you be looking for?
In machine suppliers is always a huge topic. In processability of these materials, of these manufacturability of these sensors or optics is always a big topic. The combination of both, getting the material into the process, getting a full optic or a full package out of the process with a high yield, that's always big topics. Total cost of ownership is a huge topic.
I see. I have a question for you from Wave Optics. You can unmute and ask directly. Go ahead.
Patrick, just a technical question as a matter of curiosity. So in most cases, going into high refractive index means loading the polymer with nanoparticles. I'm just wondering if there are any other ways to increase the refractive index rather than using nanoparticles?
There are, but currently we don't have a solution that fulfills our reliability constraints or expectations.
And maybe just also, if I can ask another technical question. So when we load the polymer with nanoparticles, our usual concern is the homogeneity of the final material. So in terms of the DELO materials, for instance, what kind of homogeneity are you achieving? And do you have a reliable ways to measure variations of refractive index across the final material?
Yeah, that's a very good question. Actually, that is not only a question of material, but also a question of process. Interaction with surfaces can lead to separation of materials. So yes, we have methods to measure that. But again, we need the right substrates, the substrates of your application to make sure that we have all the boundary conditions right.
Excellent.
And as Jukka said, maybe to add that, the higher you go in loading and then refractive index, the more challenging it gets.
Patrick, I have another question for you from Laser Centrum Hannover. Lars.
Yes, thank you. Polymer Optics is not my home base, so I'm here to learn a bit. But coming from Laser Centrum, can you give a brief update? Cornelia just mentioned laser application. Can you give a brief status on how laser applications do with polymers?
If you're talking about femtosecond petawatt lasers, it's nothing for Polymer Optics, I would say. But if we're talking about LIDAR applications, VCSEL applications, then that is definitely possible. It depends a lot on the pulse power, frequency, but we have measurements that prove that these materials are stable in the relevant areas. As I said, not high power lasers in the laboratories.
Thank you so much. Please, Patrick, let me introduce you to an epic friend, Andreas from Marc. And you said something about your challenges you would give. Andreas, how are you doing?
Oh, I'm fine, thank you.
Can you answer to, yeah.
Our challenge as well. We make metrology and my focus is on metrology for optical components, and it's mostly measuring the shape. And so we started in high precision optics, which is mostly glass, and now we do a lot of work for freeform optics, which goes more and what we already do in plastics. And a big challenge is where we find rather good solutions is measuring like front and back side of an optical component, and using references like outer shapes or something as references to measure like different optical surface in relation to each other. And this is really important for precision optics, and I'm not so sure how important that actually is for polymer optics, probably for the more precision ones, where we also have examples in camera optics where you use that. I don't think so much in illumination where you have like these strange LED optics. They probably don't need that too much. And yeah, the interesting part is to measure these more precise optics and especially what you can do with polymer optics, what you can't do in glass, and these strange shapes, and see where people are and what are the limitations and how metrology can actually help there. There's a lot of going on at the moment, and we have quite a few examples, and what we got is like limitations are often metrology, that I do something but I have no way to measure that. That's where we focus on. So that if people are interested in that, we could maybe have a solution for you, or come to that in the future. And yeah, and if you see what precisions are, so if you have like shape errors in the range of down to a few hundred nanometers or so. So I think it's the field of illumination optics, really.
Thank you very much, Marc. It's a great company in Jena. I love visiting you there in the size building. You know what I'm waiting for,
Okay,
I hope you manage to get this for me, please. I want you here. I have a question from an EPIC member, ACM Coatings, Alexander Telles, the CEO, and he's asking in the YouTube channel, says, a question for DELO, Patrick. How temperature stable are your materials for post-processing steps like additional coatings?
And additional coatings are a very interesting field. We see more, especially in the high precision area, that people want to apply anti-reflective coatings on top of polymer optics. The temperature stability is not so much the issue, but you have different CTEs than in glass. That is the bigger topic. So you apply your coating, your polymer optic cools down, you have the CTE, so the shape changes slightly, you get stresses in the coatings. That is a topic where coating design, lens design, and polymer optic or polymer that is used need to match. So that is something where we really need to get the whole supply chain together and work together to solve that, because it's not an individual aspect.
Thank you very much, Patrick. If anybody is looking for ultra black coatings, you have to go to ACM Coatings. So you can also go to Surrey, they are also members. So they are both fantastic. And I want to say hello also to new people for the first time ever at an EPIC event. And we have a company called Navitar, which is a big player in the field of imaging lenses. And Ian is here with us. Ian, how are you doing today?
Hello. Yes, this is my first meeting.
That's right.
So I saw this over the weekend that this meeting was on, and we're particularly interested in automotive autonomous vehicle optics like LiDAR and imaging optics. And in this industry, price is critical, and we're constantly being asked, can we not make lenses with some plastic elements? So I'm interested to know what advantages, disadvantages, what cost savings we can have with plastic optics, what design rules we would implement, what shapes of A-spheres we can have, whether we should be looking at molding, taking a glass base element and molding some plastic on top of it, what limitations there are, etc., etc. What materials. Another major feature is temperature range. We need to athermalize these optics, and so I need to know what limitations there are, what ranges of dN by dt there is on polymer optics. We have a good handle. We have a good handle on molding glass optics, So we need to know what the implications are of switching to having some molded plastics.
I got extremely happy when you answered my email. I've been knocking at different doors in Navitar, and I'm really happy to have you here. Many people were taking notes while you were talking, so expect some follow-up after this. People want to talk to you. And I want to talk also to the next speaker. Let's move on with the agenda. Today we have a beautiful agenda. We're going to finish on time. Now we are going to Finland.
Jukka.
We're going to my friend Jukka. We're going to Inkron. Thank you very much, Jukka, for being with us. Tell us how we can make Inkron even better than they already is. The floor and the attention of everyone goes to Finland.
Okay, so thank you, Jose. So let me share my presentation. If I just find it from here somewhere. Let me see. Always the same thing. Let's try this one.
I'm sure it's the right one. Yes.
Yeah. So indeed, so I'm Jukka Perento. I'm with.
Could you go to presentation mode? I think it's F11.
Let me see.
Yes.
Okay, now. Yeah. So I'm Jukka Perento, and I'm with Inkron in Finland, as Jose already said. And a couple words about Inkron. So Inkron is quite focused resin manufacturer. We pretty much only focus on siloxane polymers. So we make our own resins in-house. We have an in-house synthesis for our resins. Also, sometimes we even make our own monomers, but then we are not selling the polymer or resin itself. But what we do, we have an in-house formulation, and our products are formulated, application-specific formulated products. And if you didn't know about the siloxane product, those are very transparent and clear, and thermally and optically stable. So it's a good starting point for optics type of the applications. And because we have pretty good know-how what comes to how to design these polymers, we are able to make both extreme low and then high refractive index coatings using our technologies. The markets we are targeting currently, it's sort of a threefold situation. We work with the printed electronics, then we work with the optical devices like nanoimprinting and diffractive optics, and optical packaging type of the products. So we have like for optics packaging, we have adhesives, thermally conductive adhesives, for example, for LED packaging, and the encapsulant materials, high refractive index encapsulants, and typical applications are LEDs, lighting solutions, and sensors, and so forth. On printed electronics side, we have both screen and inkjettable conductive inks and dielectric inks, and supporting like a structural adhesive solutions, typically for wearables or in-mold electronics type of the applications. And then probably the main topic of the day from our point of view is the optical devices and nano-imprintable coatings and diffractive optics. So we have a quite wide range of indices, starting from a very low refractive index going up to very high refractive index and anything in between. And let's say typical applications we are targeting as of now are AR waveguides, 3D sensors, and generally taken diffractive optics type of the applications. Yes, because this time for the presentation is quite short, so I didn't go into any depth with the presentation. But this list of different refractive indices maybe gives you an idea what sort of materials we have. So our lowest refractive index we can make is starting from 1.1, or actually in the lab we've been even lower with our coating, but the standard product is 1.1 and up, like 1.25, 1.4, and then starting from the mid-range, 1.5 range, those are nano-imprintable resins or coatings. Like nominal refractive indices are 1.7, 1.8, and then 1.9 and over. We don't have a 2.0 nano imprintable yet, but we are quite close to that anyway. And then before you, Jose, have a chance to ask what can Inkron do for you. So we are specialists in high and low refractive index coatings, and we are putting lots of focus on nano imprinting and diffractive optics. So we have a nano imprinting tool in house, so we can offer the support to optimize and customize our formulations for the diffractive optics and also do the nano imprinting in house. And what we are looking for, we are of course looking partners interested in working with us with the new designs and applications, but also we are open for the EU project proposals as well. And that's pretty much ends my presentation. We do have some new products coming out soon, so stay tuned.
I'm always tuned to what you guys are doing. I'm actually quite amazed. First of all, with the growth of Inkron. Second, how many connections you're always making and how always you follow up with every introduction we make. So it is great to have you at EPIC. And we have questions for you. The first question comes from Neuchâtel, just next to the lake. They are such a beautiful city. And we have, of course, with us, Thoralf. Thoralf, how are you doing today?
Fine, thank you, Jose. Thank you very much.
What question do you have for Jukka?
So, hello, Jukka. I tried to fetch you already at the Photonics West, but for a certain reason, it doesn't work. We work on micro optics, means that we have usually much thicker layers than a few microns.
Yeah.
Can you imagine to use your materials for much thicker layers than the diffractive optic space?
What sort of thicknesses are we talking about?
We go to 100 to 500 micron.
And which refractive index?
But that's for the moment is maybe not so important as long as it is more solvent-free than solvent-containing.
With the certain formulations, yes, we can make also thick layers, like a couple of millimeters. Mm-hmm. But then the solvent-free and viscosity and refractive index combination is sort of a challenging. So we have, for example, we have 1.65 encapsulant for LEDs, and those are typically like 1 millimeter thick.
Ah, okay, good. That's good to know. So we should get in touch and see what we can do. There's another question, Jose, if you allow.
Of course.
The structural integrity of the material. Let's put it like this. So is softness, is demoldability, because we are usually molding this kind of materials. So is this material easy to handle for molding, demolding, replication, and hardness after baking and after curing?
Well, as I mentioned, because we are making the resins ourselves, so we can modify them within a fairly big range. So maybe we should have an offline discussion if you tell me your specs, and I'll take our technical guys with me into the meeting, and then we can see if we can reach your targets or not.
Well, this is an excellent idea. Thank you very much, Jukka.
Okay,
and thank you very much, Thoralf, and thank you everyone at SUS Micro Optics for the keep strong support that you're doing, and actually for leading the European revolution in micro optics. You guys are doing a fantastic job. And I would like to now go all the way to the other side of the world. I'm going to go to Japan. And why am I going to Japan? Because I really, really want you to understand the story that I've been coming across in the last weeks. DNP is a one-stop shop. Naoya-san, thank you very much for joining today and for being such a strong supporter of EPIC. Today is your meeting because here you have everybody in the room can do business with you. Can you tell us why? I have something to share from my screen, but I would like you to explain this slide that I have seen from you.
Okay, thanks.
Yes.
Yeah, so that the Nippon Printing is in Japan, and we are one of the photomask supplier for leading edge semiconductor manufacturers. So at this time, I would like to focus in on mold. So we have a multi-e-beam mask writing system from IMS in Austria. which has 256K beams in the column, so that we can make a very smooth and precise features on a substrate. So you can see the right-hand side. We can make like a quartz mode, which has a minimum feature size of 14 nanometer Lyons spaces, and also the multi-step 3D features on the quartz mode. Of course, we can replicate this mode to on a soft mode like a PDMS, and we can also supply the final products of DOE. But the focusing point is we can make a very precise and small features on a master template kind of things. So if you need a kind of these features, please contact us. And but this is the photomask area, so that substrate size is limited to 6-inch square. So that's only the limitation. So that's all I have this time.
Thank you very much, Naoya-san. I have been checking the news, and I think it was last year when you announced a roadmap towards going to 10 nanometer resolution molds for nano-imprint lithography. What is the status of this, and how can we help you especially?
Oh, yeah. So yeah, we are trying to create a 10 nanometer or even less, but it's very depends on beam quality. I mean, current electron beam size is just a 10 nanometer. So it's quite difficult to get 10 or less than that. So that we need to get the beam writer with like a 5 nanometer beam size kind of things. And also electron beam resist polymer to resolute such kind of small features. So that's our challenge.
Anybody would like to comment, address, or perhaps collaborate on that particular challenge? When it comes to quality of the beam, sorry, Benjamin, did you raise your hand? No, he didn't. By the way, there's obviously some potential cooperation there. But during the meeting, we're going to address a couple of these points. But what I would like for you to understand, for the rest of the room to understand, is that DMP is really a one-stop shop. And when it comes to going into very high-resolution nano-imprint lithography, they can give the molds, they can also make the machines, they can make the prototypes, and it's a great, great company to have in EPIC. Arigato! Thank you very much for being part of this fantastic adventure. And now I'm going to go to where polymers really like to go, to harsh environments in low cost and volume production. I'm going to go to SABIC. I'm going to go to Bernd, because I want to really understand how your material can help companies like Khatod in Italy better than they already are. The floor and the attention of everyone goes to SABIC, goes to you. And I think you may be muted.
Thank you very
yes.
much. Yes, I have to now come to my presentation. Little bit tricky here. Wait. Sorry. Yeah. Okay. Now it should work.
It works perfect. Oh, no, now it doesn't work. Now we are seeing each other again. So let's go to the bottom of the screen.
To share screen. No, that was actually this one. Share.
Yes.
Yeah. Okay. And now I
perfect.
Have to
yes, the floor is yours.
That one here. I have something here on my.
It works perfectly now.
Okay. Yeah. Not on my side. Okay. So sorry. I tried to be prepared a lot, but. Okay, we are talking today about high volume production. If you think about the sensors, typically if it comes to IR sensors, which are widely used, and just if you think about mobile phones, 1.5 billion production number per year, you see these infrared proximity time-of-flight sensors also in PCs, robot cleaners, gaming, toys, drones, security equipment, vending machines, and you will see that in LiDAR, in 3D gesture control, And in various Internet of Things devices, you can imagine about the volume and the need to be to use this material. Actually, we are coming from designs with wave soldering, what you see here. So you see here the PEI, a thermoplastic material as a lens material. But to go to all of these applications, you have to go to miniaturization. And this means you have to go to surface mount technology. And just look at that picture. This is an IR emitting and receiving device for proximity control. It's as big or as small as a part of your fingertip. Now, imagine if you want to go into these small parts, surface mount technology is key. And we heard in previous discussions, it's always a question of temperatures. Temperature resistance, of course, the thermal expansion of these materials when it comes, for example, to the reflow soldering. So really soldering these devices to the PCB board. And also for secondary operations, like if you put in additional coatings, if you do lacquering, etc., you always have to handle higher temperatures. So the top material in our portfolio, the XTEM, which is a TPI resin, this can withstand this reflow soldering process. And actually you can injection mold a lens overmold with a housing, and you are avoiding really all these secondary operations, which you need using glass or using also epoxy. We can even do the JDEC standard level 3 with our resins. Now, as mentioned, temperature is always key if it comes to thermoplastic resins. And what is a compromise? Actually, high transmission solutions are, for example, PMMA or PC. And the higher the thermoplastic temperature resistance goes, the compromise is the lower is the transmission, but still in an acceptable range. I will show in the next slide. So we have solutions, robust solutions up to 210 degrees C with a PEI resin. We can go up to 260 degrees C with a TPI resin, and even working on the next generation where we do a really robust reflow to really cover all these different settings and machine types of reflow soldering machines. And key is actually the temperature where the lenses has to go through. It doesn't matter whether it's a flash lens for a camera, automotive camera lenses also have to resist higher heats, and the sensors. About the transmission. Here you see for the PEI, actually we are around the 88% transmission. We can, of course, increase it by using anti-reflective coatings. For the reflow soldering material, we are below the 80% transmission. Compared to glass, of course, it's lower. But with glass, you cannot cover these extreme high volumes. And now looking on the RI, we heard a lot of questions here as well. Yes, we can provide, of course, a 1.7, but only at the 408 nanometer visible range. If it comes to the IR, we are around 1.63, 1.65 in RI. But remember, thermoplastic parts can be injection molded, can be injection compression molded, or can be hot embossed. And there you have really design freedom. If you can immediately start doing designs, the parameters of our high-end thermoplastic resins are in the ZMAX Optics Studio. So available, you can start. And yeah, you have a big partner with SABIC. So we have about 34,000 employees. And looking to the all over SABIC businesses, we are the third largest company, chemical company. Now, I know there are questions. What can I do for you? I hope I was very clear on these offering on materials, but how can you help me? Let me know the context to the optical designers, to these companies who are looking into injection molded lenses, especially for high heat. Let me know. Let me know where the challenges are for epoxy, where we can help with thermoplastic resins. And now looking forward to the questions. Thank you very much.
Thank you so much for this great talk. And thank you for being open to this kind of collaborations as well. So you told us what you can do for the others, and SABIC is huge, and it's really nice to see that you're going towards this. Let me see first if we have actually.
I have a question. Yes, because we have one of your customers. I think already. I don't know if it's public or not, but I think I just revealed it. One company in the room, first ever EPIC event, is Willem Weber. Thank you very much for joining, Andreas. I think you have a question for our friend Bernd.
Yeah. So at first, thank you for the talk, and we are always looking for new optical materials. The topic we are doing a lot of research at the moment is the combination of thermoplastics and silicon as a multi-injection molding. Do you have already materials which can be used for overmolding with silicon, or do you have research in this area, or do you have some proposal which one we should use for testing?
Not right now, but there should be not that challenge if you overmold the X-Temps with silicon, especially because of the high temperature resistance. It's possible overmolding silicon to PEI or TPI. That should be possible. Actually, since we are material supplier and we are not supplying silicons, we did not spend so much investments in this at the moment or in our TNI. But let's have a talk offline, and we can collaborate here. And if this is interesting for us, we have a lot laboratories and specialists looking into that and can support you.
Great,
thanks. This is the whole point. This is the whole point from this meeting. And if you want introductions, you just shoot an email to Jose. He can help you a lot with this. And please let me see the questions that we got from Cristiano from EVG. So EV Group, Cristiano, please unmute and you can ask your question.
If you need to overmold on MMA, it can be done, so it's not a problem. The unique thing that you have to consider that in order to inject optical silicon, you have to create a vacuum inside the tool. So it's difficult to make a co-molding. So it has to be done in 2 steps, but it's possible.
Okay, so we have a lot of optical silicon production here, but the topic always is, of course, pricing of optical silicon as well. And if you can, of course, combine it, so you only make the important optical parts out of optical silicon and the rest of a TPE, best in optical TPEs, it would help, of course.
Yeah.
So back to you, Cristiano. You can unmute.
Yeah, hi Bernd. So we know each other already, and EVT also doing hot embossing and providing hot embossing tools. And so my question is SABIC planning in the future also to provide substrates, and not just the pellets, but the substrates as well? And if yes, which flatness do you think you can achieve? That would be one question. The other one, you said you have 164 at infrared. What is the refractive index at 589? Because I think arsenite want to know this as well.
Okay, Christine, I will send you the presentation afterwards. It was mentioned there. It's higher at 5. You said 5 to 8 nanometers.
589.
589. Yeah, it's even higher. It must be around 1.67. But I can provide you the name, and you find it also in the presentation. Yeah, so we are a supplier of granulates, but we also have a film industry. So if it comes to sheets or films, in the moment, let's say they are more on the PC side. We don't see that dynamic on the PEI side. It's possible. We showed that we can provide PEI films, but the market demand is not big. So let's talk. Let's see where you see the demand, and we can raise the capacity without issues.
Yeah, let's talk to Web Optics, for example.
Lot of work for you. A lot of work for you today, Jose. And SABIC, for SABIC, we have more questions now from Brussels Photonics. Please, yeah, excellent.
Well, actually, Christine just asked the question. I was also wondering whether you were only supplying granulates or also in sheet form. So you just answered that question. Thank you.
Excellent.
And sheets are available from SABIC and also from second suppliers. So there is industry globally making PEI films. It's not exclusively SABIC, and we are proud that many companies looking for that raw material to make films and sheets in different thicknesses and sizes, of course.
BFOT, Brussels Photonics, the VUV in Brussels is one of the companies who have positioned themselves in the center of the ecosystem for R&D. Actually, 20 years ago, they invested heavily on a synchrotron, and since then, they have really helped many industries in this sector. Jürgen, I'm very interested. You have a meeting here with the rest of the supply chain. Can you answer the EPIC question on your first ever EPIC meeting? What can you do for them? What can they do for you?
Well, I heard already very nice input from many different companies here. Huh? So from the material supply side, I think we really are very interested in novel materials that can also be compatible with higher temperatures and so on. The story that we heard a couple of times. From the supply side, so what can we do for them? Well, we also try to be active on all kinds of free-form optical shapes in plastics or also in glass. We go from mold manufacturing to replication. We do both hot embossing and injection molding in-house. So we kind of provide also a little bit of a one-stop shop solution to some extent. And we're definitely interested in teaming up with some of the others here today. And also, as mentioned before, metrology of the freeform optics is also something that pops up many times. That it's not easy to. I mean, you can make something, but then it's a different thing to be able to show that you have manufactured something according to the specs. So also on the manufacturing metrology side, we're always looking for novel things that can help in further optimizing the production process.
If you are in the need of a challenging prototype with low TRL, these people are the best possible contact. They're also the coordinators of the ACFAST initiative. So they already have the tools and the funding to help supporting the manufacturing of the first prototype. So Jürgen, thank you very much for joining this first ever EPIC meeting. I want to see you more often. And I want to go to a good friend. I want to go to a company called CDA. I want to go to Pia, because Pia is one of these people that when she's at the meeting is automatically better. Because CDA is one of these companies that we are always extremely happy to have for supporting on the metrology solution for micro optics. Pia, thank you very much for joining. Tell us how the manufacturing of polymer optics is performed at CDA. The floor and the attention of everyone goes to CDA as a polymer optic manufacturer. Pia, I think we have you muted. We cannot hear you, at least I cannot. Pia, can you unmute yourself? I think you need to unmute yourself. I don't have the authority, neither the power. No, yes.
Now, I hope
yes, perfect.
Can you see my screen? Not yet.
Not yet. But we can see you, and we can see you happy and excited for this particular meeting on Polymer Optics. Most important is to identify the potential collaboration. The floor is yours.
Okay, thank you very much, EPIC, for giving this this opportunity to tell you about CDA. I see already a lot of familiar faces, so a lot of you already know something about CDA. But the ones who don't, I want to tell you that the mass manufacturing of wafer-level micro-optics on polymer, that's pretty much all what I'm going to talk about, and those are really the key words of my presentation. Our mission is we inspire and manufacture value. And this is something that, that it's sometimes a small text. This text is under our logo, but it has a greater meaning at CDA. The inspiring means that it comes from we have different processes at CDA, and we want to inspire our customers using these different technologies. And the manufacturing comes from that we not only do optic design and prototypes, but our main focus is manufacturing. CDA is a contract manufacturing company with a lot of scalable and flexible production possibilities. We have over 25 years of manufacturing experience and micro-optics manufacturing since 2005. When I talk about customization, it means that we have no standard products. They are always very custom specific. Micro-optics means for us both diffractive and refractive optics. We have wide range of component types which are listed there in the under. We also make some lens packages and integrated optics. Polymers is the topic of today, and polymers is very important for us because it gives us an option to provide variety of types of optics based on the material. So we do not do any polymer and glass versions. Our main markets are consumer electronics, automotive, and industrial, but it's not only these, but those are the main markets that our components are applied. In the consumer electronics, in AR, VR, mixed reality, facial recognition, and near infrared illumination, those are the types of applications where the volumes are very, very large, and usually the lifetime of these products are very short. Automotive, in applications such as HUD diffusers, LiDARs, and different kinds of projections. And there, you know, the life cycle of these projects are usually much longer. The volumes are the medium. And then we have more of the niche markets, industrial, which includes robotics, 3D sensing, and some of the optical encoder discs. We have quite a unique combination of different technologies. The main process portfolios that we have are mastering and tooling. This is basically an insert that we put into our molding machines. We have three kinds of replication processes: impression, conjection molding, injection molding, and then nano imprinting. We have different coating options. We also do printing. We can do optical testing in the lab, and then of course, then in the high volume setup. We can stack. We can have three different singulation processes. We do sort and picking, and then we can also do some module assembly. The project always starts with prototyping, and mostly of the productions are done in clean room. Either it is that encapsulated equipment, or just in the whole, even the equipment are in the clean room. From the service point of view, that each project always get assigned project manager, and they are then the point of contact for the whole project. It's also very important to mention the IP protection. Once you design a customer-based products, the IP issue is very sensitive, and we've known for the last 25 years to hold on to that topic. Due to our automotive clients, CDA has an IAFT 16949 certificate, and therefore we also have all these different databases, IDE, VMI solutions in place. So from the optical functions and feature sizes, we use our own software mostly. However, some of the commercial software is also available. However, the own code that our optical designers use, they take in consideration the manufacturing parameters and the material shrinkage and so forth. Usually the feature sizes that we work on are 0.5 micron and up. It varies a little bit of how large we can do. We are mostly in the micron range, and we would like to have the aspect ratio to be as close to 1 as possible. The optical functions are from the DOEs typically do is a beam splitting, deflection, combining different beams together. You can collimate, you can do spot arrays, lines, tailor-made diffusers, and of course pattern generators. And the pictures that you can see there on the left-hand side, that's actually a microscopic picture of CDA's logo. And we have MLAs and some of the Fresnel lenses. At CDA, we constantly are pushing the boundaries, both technologies and product-wise, and we are currently always working on the further developments, which here is listed a little bit of different programs, not in detail what we have. So we have different programs and products, materials, processes, and then the operations. I also want to talk really briefly and take this opportunity of an exciting EU project called Phenomenon. We are currently in the last phase of this ACE project, and it's really interesting to see all these different pieces come together. The Phenomenon project, it's a laser manufacturing of 3D nanostructured optics using advanced photochemistry. We have there great work that's done by CRNS in material development, Fluxim and ICFO in optical software development. We have also some revolutionary work by IMT and AMEN on laser processing, and then also the production of small micro-optics and machine building by NPO. At the end of the project, we will also build 5 demonstrators for Thales, PSA, FNMT, Design LAD, Flex Enable, and they will be then shown at the end of the project. I want to also point out this special meta lens that was designed by ICFO and MPO. The feature sizes of these meta lenses are between 100 and 450 nanometers. And for the tradition of EPIC comes the questions, what can we do for you and what can you do for us? We are looking for partnerships, new materials. Materials is a very, very big topic in polymer optics. I think that those are the ones that really make the big difference. We are looking for high volume customers. We have the capacity for that. And of course, always the challenges. What we offer is partnership. A lot of the work we do is really a partnership. You develop new products together. We offer an optic design and manufacturing of customized micro-optics, R&D developments, and testing materials. So thank you very much for this opportunity to tell you about CDA.
Thank you so much for this very nice talk and for being ready with the EPIC questions. That makes us really happy with that. I already have the first question for you from Neuchâtel from Swiss Micro Optics.
Yeah, hello, Pierre. This is Tora from Swiss Micro Optics. So we are producing on wafer level. And we look always for, also within our project Fabulous, actually, which is on freeform surfaces, we also look for opportunities to combine different technologies a little bit. So would I be interested in knowing how large is your largest surface you can treat? So for the moment, I see it's 100 millimeter or whatever. Could you also go to 200 or 300 millimeter wafer-like structuring? And then what is the aspect ratios which you can do usually? So for instance, if you do look like at these large Fresnel lenses, which have a very steep flank on one side. So is this a problem for you to have elements which are height of, let's say 500 micron with a steep flank, or is this easy? Thank you.
So our core area is really in the micron range. So let's say from anywhere from 500 nanometers to, let's say, 20 microns. So that's where is the comfortable range. Mm-hmm. Using our partners, we can also do then the tool making for deeper structures, and then we can mold them at CDA. But let's say if we go more in the 500 micron range, that's too much. So I would say that in the 250, 300 micron is pretty much the maximum.
And the surface, if you think about the surface area of the wafer, can you go to 300 millimeter wafers, for instance?
No, we have a limited wafer size. There is, so we are mostly suitable for very small micro optics. Mm-hmm. We have a special wafer which has a center hole, mm-hmm. and that limits us of the footprint of the element. So let's say 25 times 75, for example, would be one. Or if you are in the circular format, let's say 38 millimeter diameter.
Thank you very much.
Thank you very much. Let me see if we have another questions from our speakers here. And I have a question for you from Christiane. Christiane, please unmute.
Yeah, a question with the meta lens. I think it's very impressive you showed the meta lens, and we see a lot of interesting meta lenses currently. So my question is it fabricated by injection molding or was it an imprinting process?
This meta lens was produced by a company called MPO. And it is more, and I would say in the 3D printing type. So it's in a printed method.
Mm-hmm. Okay, thank you.
Thank you very much. Please allow me to introduce Henning from ILIS. Henning, please unmute and answer the epic questions. What do you do, and how can the others help you?
Yes, hello. My name is Henning Katte. I'm the founder and CEO of a company called ILIS, based in Erlangen, that is very close to Nuremberg in Germany. Thank you very much for the invitation. So some of the members I know already, some other I don't know. And we are on the supplier side. We produce measuring instruments to measure stress birefringence in different materials, transparent materials, such as glass and plastics, of course. And many of our customers use our imaging polarimeters to control and optimize the stress birefringence in their products. So, and that is what we can offer. So we can provide the measurement technology to control the stress birefringence in materials and also in components, so that polarization changes are not an issue. And there are many applications demanding for that, high precision optics, semiconductor optics. So that is mainly what we do. We also offer some software for doing color measurement and transmittance measurement, where I also saw some graphs that there might be a need. So that's maybe in a nutshell what we do.
And what can the others do for you? So what kind of collaborations are you looking for? What kind of introductions can Jose do for you today?
Well, I followed some of the talks, and one was about creating diffusers on glass, and we use diffusers in our instruments. So I would be interested in that, and if it's not what kind of diffuser it would be. So I took some notes for me, so we might be able to find some suppliers among our customers. So it's a win-win situation sometimes for both sides. And that's quite typical for us, that our customers can be also suppliers at the same time. So it's very interesting to be in such a networking environment.
Thank you so much. We are very happy to have you today here. And we are also happy to have Moro from SAIS Getters. Please unmute and answer the epic question for us.
Yes, thank you, Sana. Let me introduce briefly myself. I'm business manager for the dispensable products within our specialty chemicals division. We are really involved in the encapsulation materials, basically dispensable dryers, dispensable selective getters, active barrier sealants, and different kind of fillers. So this field today is very new to me, so I would like to know if anyone is interested in some collaboration. What we can do is provide our materials, our expertise in polymers, in hybrid materials, especially for the encapsulations, but not only in this. And we have an R&D with many experienced people capable also of making simulations and to make servicing for our customers. So I'm very happy to be here. I'm learning a lot. So I hope to gain some more information on this new field for me. Thank you so much.
Mauro, we have been talking about, sorry, one quick question, Sana. We have been talking a lot about getters to actually protect parts of the chips at wafer level. Can you update us on that is going? Because I know that getters have been used to bring photonic integrated circuits and to bring electronics to harsh environments. How does it work? And can you do it at wafer level now?
We have different customers now. This is something new for us. For example, telecommunications or optics or photonics. We provide dispensable dryers to be dispensed in air with different means of deposition, like needle dispensing, inkjetting, blading, etc. And usually we are asked to provide some high capacity dryers, which can be deposited directly by the customers in not controlled environments for some hours. So we work on the kinetics of these materials in order to be usable. And then we also work on the different kind of curing from thermal to UV visible in order to be fully compatible with their process. So as said, usually we provide the materials and our customers use them. And of course, we can fine tune the properties of our materials in order to be used with their processes.
See, yeah, it is very interesting because I want to go back to Navitar. I want to go back to Ian, because in the very beginning, Ian, you were talking about the automotive sector. You were talking about the different glues, optics to go to these harsh environments. We have heard from SABIC that they make the polymer for these harsh environments. We have already now heard from SAIS Getters that we already can actually protect lenses and protect any part of the instrument for harsh environment at the same time deliver polymer, actually dispense it at wafer level. And now we're going to hear actually from Volvo in a couple of minutes. But before Volvo takes the stage, I want to go to you as an integrator. Ian, can you tell us so far from the presentations that we have from SABIC, from SAIS, from ILIS, from all these people, what kind of challenges you see in the supply chain, and especially what could you do for a car maker like Volvo with the rest of the supply chain?
Well, my point of view here is to pick up information from the material makers that are making these polymers, so I can find out the material properties that will be useful for me, and the companies that can do the moldings to make lens elements that would be suitable for me. We are working with our customers integrating in particular LiDAR and automotive imaging lenses, and their customers are tier 1 automotive companies. So I'm particularly interested in further down the chain to my supply side. So I can. I'm an optical designer, so I want to know what features I can include in the design with what materials.
Thank you so much, and this is very interesting. Maybe we will hear more replies to these challenges soon, but I am very happy to have in the room with us an epic friend now, because this is your second time you join us for an online technology meeting. The first one was for automotive lighting. And today, again, we heard about automotive application of polymer optics. I'm very happy to present Paul-Henri from Volvo Cars. Thank you so much for joining the meeting today. And please tell us, what is Volvo looking for?
Yes, hello. So do you see my screen? Yeah?
Yes. Yes.
Yeah, okay. So I will try to give you just some insight about what is needed for automotive lighting application. So my name is Paul-Henri Matha. I'm the technical leader for Volvo Cars in Sweden. But perhaps you have seen I have a French accent also. So what are the usage for polymers? So in automotive lighting, so I put a picture from Arkema, but you can see that we use it for headlamp, for the front, we use it for the rear lamp, and we use it also for interior lighting. Yeah. So what are the stakes we have at Volvo Cars and for other car makers? So we have stakes for outside and for internal components. So for outside, I think you know, but the characteristic we want to have for the lens is a good UV resistance, a good scratch resistance, good aesthetic rendering, and also a good mechanical resistance, especially for pedestrian crash. And after, for internal components, so we want to have a good optical efficiency, and we want to have also good thermal properties. So I will focus especially my presentation about internal components, because I think it is the topic of today's meeting. So optical properties. So the main things we have is two different applications for optics. It is when we want to diffuse light, so with in a light guide. So it is the picture on the left with the example of the Peugeot, for example. And after you have the reflectivity, it is the example of the reflector, so parabola reflector, for example, when we use a plastic part without metallization or something like that. So the good properties we want to have is a good transmittance or a good reflectivity. When we use a diffusive material, we want to have a high optical efficiency. And also, we don't want to have a color shift when we put light in a long plastic part. So especially when the plastic part, the length is more than 500 millimeters, we have, and we can see on a lot of cars, a color shift. So the light at the beginning is white, and at the end, the light is yellow. And this is not acceptable. So also what is important about plastics and polymers is the thermal properties. So you can see a simulation of Volvo XC60 headlamp. So it is a thermal simulation when the LED are on. And you can see that so you have some thermal increase, and especially on the plastic. So in this case, it is a reflector, but we can have LEDs also in other parts. So the plastic will be at 80, 100 degrees, 120 degrees. So when we use a plastic for optical system, we need to have a high efficient plastic with high thermal properties. So especially sometimes the PMMA can be at the limit, and we need to have polycarbonate or polycarbonate with a high temperature property. And also with this environment, we need to have no color shift also, because sometimes at 80 or 100, 120 degrees, we have a color shift. Yes, and my last slide is about what are our needs. So I just put an example of the XC60 headlamp. So you can see on the left the picture, and we can see when you dismount the part, the component we have for the optical system. So you can see, for example, white reflector, so with a very high reflectivity. And after we have inner lens or sort of light guide. And so you can see on the section before the light guide, the thickness, for example, is 1 centimeter, something like this. So it is a big thickness, so it is very heavy. And on the side, you will have the LEDs. So what is important for our car makers is to have more sustainable material, especially if we can use a recycled material to do this sort of functionality. to have also less coating. So, for example, for the outer lens, we have a UV coating because polycarbonate. So could we remove this coating and use PMMA, for example, for front lamp? Can we remove also the metallization and to have a very good reflectivity only with white material? Perhaps also can we increase the transmittance, reflectivity, and homogeneity of this plastic component? And also in the same time, can we reduce the weight? So if you see the Torse hammer plastic part, for example, or XC60 is around 400 grams, something like this. So we would like to be able to have it with lighter weight. That is the end of my presentation. I think I can answer to a lot of questions. I was not there before. I'm sorry, but it was very interesting, I suppose, but I was not available. But so I don't know exactly what was discussed just before, but I can answer to all your questions. Thank you.
The whole thing until now was an introduction for your presentation. So everything that we were talking about is how can we help Volvo when they come here with their challenges. And you came with very interesting challenges today. Thank you very much for your presentation. You talk about a more sustainable material, less coatings, better transmittance, reflectivity, homogeneity, and weight reduction. So let's address this. So I'm going to open right now the floor for questions and potential collaborations. Who is the first one to raise the hand? As you can see, this is a very, very shy community. They have no questions or potential for collaboration. Normally, I actually, yes, we have a question from Bernd, SABIC.
Oh, yeah, this is also our field of expertise. Actually, it's not this really high heat. When I'm talking about high heat, I talked about 200 degrees C plus. We have a team of especially for automotive lighting. I will bring you into contact with them. So we have a lot as you, especially for your demand, the high reflective materials. Yeah, you know our Lexan for the outer window, but the interior parts, we have a wide portfolio. I will provide you the contract.
Before I give the floor to the next question, which is Marc, I am curious about something here. I want to ask you, Paul and Bernd. So Bernd, from SABIC, they make material. And Paul needs optics. So there is a step in the value chain, right? There is a company that we need to connect SABIC with Volvo. Is that right, Paul?
Right.
Yes, but we are in contact with SABIC or with Covestro or with Arkema, with Evonik, a lot of companies. So we work together because we have to develop new grade of material. It is very important. So we are in contact together. But I can discuss again with SABIC because it's a good company. And yes, perhaps for polycarbonate, we use Lexan especially for outer lens, but not for optical system. Perhaps we should use more. I don't know.
There we have higher grade. Yes. Okay.
We have one more question. If SABIC is a great company, UPMT Wielandts is also a great company, all the way in Belgium, in Liège. Marc, what's on your mind?
Yes, hello. Thank you, Jose. Well, we are not a big company. We're the smallest company probably of all of you. So, but the question is about types of the evolution of headlamps for cars. Do you also at Volvo have interest for new kinds of headlamps using lens arrays, like micro lens array headlamps?
Yes. All the car makers investigate this micro lens array. Yes, so we are interested. The main problem we have today is about power consumption because the optical efficiency of the micro lens array is quite small, and the price is also expensive. But we are investigating this technology. Yes, especially for low beam, not for signaling function, but for lighting function.
Okay.
Any further questions? When it comes to molding the material, molding the optics, is there any particular challenge on the shape, on the metrology, on the resolution?
Yes, we have when we have very thick optics. So you know the thickness can be 1 centimeter. Sometimes it can be 2 centimeters. So if you inject the part in one shot, it can take 20 minutes. So you have 2-shot systems, so 3-shot systems, 8 K tools sometimes. So it is very, very complex. So complexity is cost. So perhaps we can simplify also the tool to know some better things, to do some better. the tool something like this. So it is something we would like to investigate also.
Let's investigate it. This is the best time possible. So I'm going to go to Sonex. Benjamin, we are looking for a company that helps us mold very thick optics. Can you maybe help us on this?
Yes, sure. Thank you, Jose, first of all, for organizing this great meeting again. My name is Benjamin Bulla. I'm a managing director of Sonex, and I'm happy to present our company very briefly. We are doing ultra precision manufacturing, and among those products, we have molds for molding thick LED lenses for automotive lighting applications, such as probably in the Volvo cars are used. And we also produce molding masters for imprint lithography or for the UV curing process of micro optics. We have a variety of applications. It goes really from lighting to camera lenses and other imaging applications.
Paul, I am also, well, obviously, I think the two of you should speak because when it comes to the molding of the thick optics, Sonex really has some particular added value. But Paul, I'm interested when you talk about metallization. Could you elaborate a bit on what kind of metallization coatings would be, your Santa Claus Christmas list after the meeting today?
No, my Santa Claus Christmas list is to remove the metallization, because metallization, it is some aluminum we put on the plastic. But after, if you have metallization, you cannot recycle the plastic at the end because it is not possible. So we want to remove this metallization. And if we want to remove the metallization, we need to have a reflectivity of the plastic, which is the same without metallization. So I know that some white plastic has been developed, but the reflectivity can be still improved. So that's why we want to remove all this coating, because if you have a coating, you cannot recycle the material at the end.
Did you tell me the index value?
It should be 90% reflectivity.
90%. Anybody can help on that? 90% reflectivity of optics. Hands raised. Potential collaboration here. If whenever you need something on the R&D side in this community, I always look at my friends in Graz, because Joanneum Research is being one of the companies who has helped incorporating high TRLs from the low TRLs value. Joanneum Research is represented today by Paul Harman. It cannot be better represented. Paul, thank you very much for joining this meeting. You have seen the challenges from Volvo, especially on removing metallization, removing UV coatings, actually having very homogeneous optics, reducing the weight. Anything resonated with you on this?
Yes. Hi, Jose. Thanks for introducing me in this discussion. In fact, reflectivity of polymer materials is not just a matter of the material. It can also be a matter of the surface structure that you're applying to that. We are, for example, trying to provide specific surface structures which have their optical effects from their structure rather than from the materials. So if you think of anti-reflective structures from moth eyes, and these things can be discussed. But I think it really always depends. It will be always a custom designed problem, and we can think about your requirements as a research institute to do a certain prototype in the way of, for example, molding inserts. So we have a lithographic technology available, which goes through grayscale lithography or even two-photon absorption lithography over a replication process to certain molds that can be galvanized, and we can produce, for example, a injection molding insert with different structures that you can use to improve or alter your optical properties of the injection molded parts.
I think there's obviously some room for cooperation here. Paul, more things, don't worry. We are not letting you off the hook. There's more things I want to discuss with you. The first one is, are you looking for any challenges on interior lighting?
Yes, we have the same topic for interior lighting, yes. But I am a technical expert for exterior. But for interior lighting, especially, we have a lot of plastic components, and we want to use a recycled material, especially. So
on that,
with crystal polycarbonate or crystal PMMA, we have not today. So it is something we would like to develop, especially for interior lighting. Yeah.
So it's very good news, because in our upcoming online technology meetings starting 31st of August for the winter run, we will have exactly a meeting on interior lighting. Isn't that correct, Jose? And that will be very interesting. So I will keep you, Paul-Henri, on the list of our
the
guests,
most
right?
important thing here is that SUS Micro Optics is a company that has fully automated, qualified their manufacturing process. Well, Thoralf should say this. I'm not a salesperson for SUS Micro Optics, am I, Thoralf? Can you tell me about the providing optics for the automotive sector? Why is SUS Micro Optics special?
Well, this is because we are particular strong in our expertise, not only in the fabrication, we have the full fabrication chain, but we also have all the optical and knowledge. But we don't do the mastering, so leave this to other partners. But without optical knowledge, you are not able to fully design the fabrication chain to have really very good products, which also can withstand the high constraints like temperature, and all the other things which you need for this kind of applications, and also, of course, the quality of the optical piece itself, because what you need is this very high definition of patterns, especially for low beams and things like this. And this is something which you only obtain if you can bring together the optical design and the fabrication and all do the optimization in-house. Yeah? So this is an important point, in my opinion.
More things for Paul. Have you considered, I think Paul Harman already said something like this, but I want to ask again, have you considered some surface structuring on the top of the optics?
Yes, we use this surface. So after we know that when the surface is very small, we need to have specific technology to be able to inject the part. So yes, so we investigate this sort of technology, but it is something we just begin to use in automotive industry for automotive lighting. So it is not something that really developed.
With laser-based processing, we have managed to make aquaphobic surfaces for actually not having the water next to the light when it's raining a lot. Is that potentially a use case? Is there interest from that?
I don't know. Perhaps yes, perhaps not. I don't know. Yeah.
If you need a partner on laser-based processing, I think my friend Lars can help. Lars from Laser Centrum Hannover, you've been quite quiet. I'm not used to this, Lars. Something is happening today. Lars, you heard the presentation from Volvo. They are talking about weight reduction. They are talking about better transmittance reflectivity of the optics. They are looking about less coatings. Anything resonated with you on this?
On the topic you just mentioned about surface structuring for hygroscopic topics, that's not my field of expertise here at Laser Center, but I can get you in touch with my colleagues that are very firm in that. That's so it's tough for me to give you the details there right now. But I heard about on your slides you mentioned something about cost efficiencies in each step. And then you said something about removing coatings because of, or getting rid of coatings because you want to recycle later on. So I would be interested if there's some, that's new for me right now, that approach, because I work in coatings, so I want to keep the coatings, but definitely you always have to go down new avenues. So if there's an approach or first ideas on having coatings that are actually that have a good adhesion to the optics, but you can also get rid of them again. Maybe that's a good avenue to go down. So maybe there's something to talk, but just some first thoughts.
I think Benjamin has another point. Benjamin from Sonics.
Yeah, I just want to comment. Maybe one idea could be to use total internal reflection for such a approach. That you use a transparent material, and by combining special properties of these materials, you can create an internal reflection in the material without having a reflective coating in there.
Mm-hmm. Yeah. What do you think, Paul? Total internal reflection could be an option?
Yes, we use that for a lot of function in lighting. So when we have no reflector, but when we have what we call edge light, so it is totally indirect reflection. So we use this technology. After we have the coating, that was the metallization, but after we have also the UV coating. So it is a coating to protect the polycarbonate. So perhaps it is a question for SABIC, but we want to remove this coating because it is expensive to produce. You need to have a big plant, and the plant it's a huge plant to be able to do this coating. And after this coating, also we know that after 3 years, 5 years, we can have some yellow headlamp, or after 10 years, which is not very good. So today, the solution we have with plastic lens is less good than what we have in the past with glass lens. You can see a Ferrari with 50 years old. The glass is totally clear and it is not yellow. So that's why we want to remove this coating to be able to have another solution without. I know with PMMA, we don't need coating, for example.
We have one more question. We go to Willem Weber.
So it's not really a question, but a comment on what Paul just said. So what we were doing for example, these rain sensors in cars, where we also have a problem with the polycarbonate. There are 2-layer attempts. So we have a polycarbonate, which is UV absorbent and takes this over the polycarbonate, which really forms the optics. So this is a way to remove the coating, but just go to a 2-layer attempt.
Yeah.
But I think you know that as well, but
you know, we had a lot of things that we can do to make Volvo even better. I drive an S60. You guys make fantastic cars, but I would like to make sure that you also have the best optics in the world by using the supply chain of the EPIC members. So I'm going to make a lot of introductions here. Your challenges were very clear. You were a star. Stay with us till the end because I come back to you at the end of the meeting. But let's continue. First of all, Paul, thank you very much. You made the EPIC meeting even more epic. We continue with the program and we go now to one company which is a market leader in this sector. I'm extremely happy to have Khatod all the way from Italy telling us how we can make better optics with their fantastic equipment and their fantastic manufacturing facilities. Thank you very much for being with us today. You asked me to share a video, which I will do from the beginning, and then you can take over with your presentation. But let's start with the video.
Thank you very much, Jose. I am Todaro from Khatod Optoelectronics from Milano, Italy. Our company is born in 1985, starting with light guides, light pipes for the first LEDs. And as the first LEDs then start to make real white light, we switched over completely to lenses and reflectors. We offer in our house 100% inside the complete optical development, the tooling construction process, the mass production with almost 72 customized injection machines, coating department, laser cutting station, gasket stations, coating department, everything is 100% in-house in order to control the quality, to control the costs, and to control the delivery times. We are known on the market because we are very transparent what we do, how we do it, and where we do it. As you can see in the picture, we have 72 customized injection machines with a production capability of approximately 10 million light points per month. We are one of the biggest secondary optical manufacturers in the world, and I think they're one of the unique one who has this production capability in-house in Europe. We are completely independent from every external supplier. The only thing that arises from outside is the raw material, but we have suppliers only in Europe in order to be sure that the material has never delays in the deliveries. Each optic passes 4 different quality controls before she gets out of the house. We use every kind of methacrylate, but also optical silicones and very special materials as well. 55% of our turnover is custom made. We have a standard product portfolio of approximately 40,000 different lenses and 30,000 different light guides and light pipes. Nevertheless, as I already told you, more than 55% of our turnover is custom made. This because there is an increasing demand on the market in order to have customized lenses and customized solutions. As we learned from our colleagues from the material supplier from SABIC, it's not only a question of the material. Everything has to be combined and developed in order to have the best possible efficiency and to be suitable for the application that you have to use. Remember that each LED has its own optical characteristic, and only if the optic is developed positively for this LED, you will have a perfect result. We have sales and stock all over the world, but I repeat, we are 100% in Milano based, and whoever would like to come and visit us is heartily invited to see that this is not only a render, but this is a real video about our company.
I want to come and visit, but Sana already told me that you already invited her, so she will be the first one to go. With most important thing, I think, did you want to share some slides as well, or shall we go to the epic question now?
No, I think we can. I think our colleagues already showed a lot of slides, so I would pass directly to the question.
I fully agree with that. I'm going to be close to be dead by PowerPoint. I see too many slides in my head. Most important, you already is your first ever epic meeting, but you already know how it works. It's the epic question. What can they do for you? What can you do for them? I don't know if we can still hear you, Christian.
Yes, someone is asking for my email address.
Don't worry, they will get it later. Don't worry. Okay. So the epic members. So we have all the supply chain. You said that you don't do your own materials. Can you give us some challenges on the materials, for example?
We use approximately 50 tons of PMMA per month. Then for sure we use also polycarbonates, strange materials like PMME, PMMA HD, Xeonex. For sure what we would need in this moment is, for example, a metacrylate that has a transmission factor that can transmit wavelengths lower than 280 nanometers, for example. As you know, now in this moment with the coronavirus, the big business is the sonification, and everybody is asking for lenses for UV LEDs. No? But it's not easy because each wavelength can be transmitted only from a determined material. So I would like to have a PMMA, for example, that can transmit 250 nanometers, for example.
PMMA for 250 nanometers. I'm going to call the epic members, everyone, the 580. If somebody has a PMMA that can go 250 nanometers transparent, please let us know, because we want to contact the people in Italy and offer the power of epic. I also was quite surprised that you said 50% of our products are custom made.
The reason for this is if your product is price-based, the risk is there will be someone who will be cheaper than you. Because as you know, now in the international market, you can buy an LED everywhere from each brand. You can buy a driver, you can buy the wires. And at the end, your product has to be somehow different than the other products. But if you are using only standard products that are freely available on the market, it will be very easily for someone to copy your product. Because remember, your first competitor is your customer. Because your customer will buy something from you at the first project, and then maybe starting from the second project, he will run to someone else and say, hey, I'm buying this. Can you make it cheaper? Right? So I repeat, your first competitor is your customer itself. So what you have to try is to customize some components of your fitting in order that you can recognize it. In Italy, for example, we say, you know, we have a lot of famous lighting manufacturers in Italy. Yeah. And when you see their fittings, you already recognize it from the style. So even if it is a street lighting and it's at 8 meters or 10 meters, still you can recognize who made it. Or if we go on the indoor lighting, Euroshop or light in building, if you see something made by Artemide or Iguzzini, Floss, Cariboni, there's always things that you can recognize because there is the customization there. And the first thing, or the last thing that you will see from a fitting is always the optical part. No? The optic is that what is outside. And you have to try to bring your company philosophy inside the aesthetic of the product. We don't make only the optical development. We make also the technical development, and we help in the customization of the aesthetical impact.
Incredible. And I think the reason that you're here is also you're looking for cooperations and collaborations. I had a comment in the chat. I don't know if it was for me privately only. He said, somebody, I don't know if he wants to remain anonymous, said even the power of EPIC cannot provide PMMAs that do not absorb 250 nanometers because there are physical laws there. But we will find a way. We'll find a way. But I want to go back to Paul from Volvo, because in your requirements, Paul, you said that you need less coating, less UV coating. Could you elaborate on this? Because I think there could be here a nice potential cooperation.
But first, I have seen that you produce a lot of components, but I don't know if you produce also for automotive lighting industry or if it is only general lighting.
We make from the bathroom illumination until the space station. We produce also for cars, motorcycles, airplanes, whatever you want.
Yeah.
We made a lot of headlights, backlights, and I know you are searching something that can replace the reflector. As my colleague already said, from SONIX, you can work with a total internal reflection. But the problem is, if you have a light guide that is 300 millimeters, your loss will be very high. No?
Yeah.
Because, okay, you have a total internal reflection, but sooner or later, this light will die, so the energy will die.
Yeah.
There are a couple of solutions that could be used as, for example, the multi-coupling in light guides, where you can spare a lot of efficiency that otherwise is lost. Personally, we already tried this wide reflective materials in order to make reflectors and recyclable materials. But as you already said, the efficiency is not very high. No? I know there are some suppliers who are claiming efficiencies of 90%, but unfortunately, in our test, this was not more than 70 or 75%. And I know exactly that this is not for the automotive market. This is not.
Okay. And do you work in Italy, especially with automotive lighting, or with also other lighting supplier? So.
Sorry, repeat the question.
In Italy, you said you work with a lot of customers, but do you work especially with automotive lighting Italy or with also other partners? Or?
Let me say like this. I don't like to make the lens for the Fiat Punto. Because it's just, if something is simple and it's just a simple optic, they don't need us. So people like Fiat, who are producing 100 million cars for the Fiat Punto, they are not interested in have a high-end solution. they will produce these lenses by their own. But if the required optics is something complex, something that they are not able to do for the material, for the surface structures, for the developing, then they will come to us. So let's say I prefer to make the headlamp of the Ferrari and not that of the Fiat Punto.
Well, but the high-end S80 is very, very high-end as well. Very reliable car. So any further questions, suggestions, room for cooperation here? I can still see that there is a challenge to go for low wavelengths. I still see there's a challenge for the lightweight. Any further question, comment before we go to the next speaker? Christian, we want to see you more often at our EPIC meetings. You are epic. It was a great EPIC presentation. Let's move on. Let's go to the next one. Let's go to one of my favorite companies in EPIC. I cannot hide this, Marc. You know how much I like what you're doing, especially when you can do the freeforms on both sides of the optics. It's so ultra fantastic. Marc, the floor and the attention of everyone goes to Liège, goes to you. Tell us how we can help you.
Well, thank you, Jose, and thank you, Sana. You are my friends, I must say. So we are very happy to be a member of EPIC and to assist whenever we have the time to these conferences. Okay, so I will try to start my presentation immediately. Where is it? Well, it should be here. And then there it is. I think we go to the first one. Yeah, okay, so let me present our company first. So Wielandts UPMT, Ultra Precision Machining Technologies. You could also say Ultra Precision Molding Technologies, as you will see. It's a small startup company in the area of Liège in Belgium. Not very far, in fact, from Aachen, so maybe we've been influenced by these people. So we are active in ultra precision machining and molding, as I said, and the goal of our company is to solve some existing problems we've seen in the past, in let's say in the state-of-the-art solutions. Here from left to right, I show that our activity is first, let's say, based on ultra precision machining, diamond turning. I think many of you know what this is talking about. And we have been doing this in the past a lot. Now this is going slower because we are concentrating on the two other branches. But in space mirrors, we have a lot of experience and expertise, and so we still do that. But as I said, well, we try to solve some problems. So the first problem we tried to solve was to machine lens arrays and all kinds of lens arrays, very steep lens arrays, in the optimal way. And we call that, going back to the basics, we just machine every lens of an array as if it was a single lens. How can you do that? Well, we'll see that just in the next slide. And then we have been thinking from the start, what can we use that for ultimately? So we also developed a technology, which is a molding technology, making profit out of that unique capability of making those lens arrays. So we say we enable your next generation optronic products. In fact, a lot is going on miniaturization and lens arrays for applications where the lens array is itself a function, but also for, let's say, mass production where you want to parallelize a lot. And so let me go first to what we call DPI. This is a patented technology. I can present it more easily by the picture or the photo at the left. You see that an add-on system on an ultra precision lathe, and this add-on system allows us to shift the part with respect to the machine rotation axis. And why would we do that? As I said, we want to machine every lens as if it was a single part, single lens, because this allows us to machine it by turning and obtain the ultimate quality of that lens surface. So in fact, a very, let's say, basic function, move the part to a known position, but you have to move it, of course, in a very accurate way, and this has to maintain ultra precision. So the complete system should be balanced. So we founded the company in 2013, 2014, developed this during 2.5 years and did no business until that. So we founded the company, in fact, to be able to develop the technology. And so we patented that by the end of 2015. And for the moment, that technology is only available inside our company. It allows us to machine lens arrays up to a diameter of 200 millimeter, and to put on that surface all kinds of arrays let's say, machined in the most efficient way. So I've put there 100% fill factor, which means that the lenses can be intersecting, and this is with absolutely sharp edges. Like I say always, it's like, yeah, when you try to focus on that, you see that this is probably only one molecule. Huh? So the roughness is very, very low, like for, let's say, on-axis diamond turning. Form accuracy also can be very, very low. And so all kinds of shapes, not meta lenses, of course, but all kinds of shapes that can be turned or freeform turned. Fiducials we machine together in the same setup. The applications for these metal parts that we deliver to our customers are injection molding, polymer on glass wafer level optics, roll-to-roll or roll-to-plate. And you will see we are a member of Fabulous, the European project for freeform lens arrays. So everybody knows automotive and consumer are the markets for this. Then the second technology we develop is what we call hi-fi optics. It means high fidelity optics. So the goal is to replicate optics, thermoplastic optics, more accurately than you would currently do with injection molding, which is a big statement, of course. But imagine that injection molding has also its limitations, while that's maybe hard to hear, but when you want to make very thick parts, and we heard that just recently, it's difficult to counteract the shrinkage, so the sink mark, as they call it. While when you want to make very thin parts, you also have limitations to the section. And that is where we have developed our technologies. So our technology is making use, of course, of the other technology for making a monolithic mold. So I've shown that a bit to the right. So you have the first column on the left side, which shows thick lenses that are molded in a two-step process where the parts are first injection molded, because we need preforms, and these preforms, we want them to be, let's say, not accurate in form, but we want them just to be with the right quantity of material. And then we, in a second process, which is a compression molding process, we call it an isothermal compression molding process, we will shape them to the final form and accuracy. And lenses will come out here with a glass quality, let's say something like 600 nanometers PV on a lens that is maybe 8 millimeter or 10 millimeter thick, and which has a diameter or 30 or 40 millimeter. On the right side, you see what we do mostly now is very thin lenses. So I go back to the left side, yeah, completely to the left side. You see there a stack of very thin lenses together with apertures. And you see, it's very, very small. And the goal is to make a stack that is smaller than what's in your smartphone, because they are sticking out of your smartphone. Is that a problem? No, but it's a problem if you want to use that for AR, because in AR, you probably want to have that into your glasses. So that's what we are doing with this technology. There's a lot to say about that. I can't go into the details because we don't have the time for that. Because we have that array technology, we have also been applying that for injection compression molding, where the thickness is okay for that. And we have also succeeded to do that on a wafer level. And so that is very useful for LiDAR applications and the kind. Finally, I come to my last slide normally. Where is it? Doesn't want to go. That's strange. Oh, here it is. So the conclusions, what can we do for you and what can you do for us? What can we do? We can probably reduce your form and roughness errors for lens array applications. We can augment your design freedom, certainly, and we can compensate for replication process effects. And very especially, we can shorten your time to production. What can you do for us? Well, we love to communicate to our customers about what we can do so that they take that into account, and because they consider this as new design freedom. And then, well, it's important, of course, that they submit their applications early in their design phase. I thank everybody for your attention. I thank particularly EPIC, of course. And as you see, we are participating to Fabulous, a marvelous logo. And EPIC, a little bit of publicity for you is well deserved. Thank you.
Thank you so much, Marc. This is really heartwarming, and it's so nice to see your unique technology. I have to say that UPMT, together with the AVG, CDA, and SUS Micro Optics, you are leading the new revolution in the European micro optics industry. And it's really nice to see this biggest change happening in the photonics. This is like the biggest change that happened in the photonics in the last 2 decades. We have here now in Europe the best micro optics manufacturers, and it's really very interesting to have you all part of this meeting today. So after this, Marc, so your answer to EPIC question was a little tricky, yeah? I want to know what kind of collaborations you are looking for. How can these companies reach out to you? What task or what challenge can you give them?
Let's say it's a bit difficult because let's say we try to solve problems that are existing both at, let's say, the replication companies, the production companies, and we can help them with masters and things like that. So with tools that are, let's say, super accurate, fastly made, but we also have a lot of contact with the end users, because when you want to make the next generation of products, then this is studied at the end user design office, and they have to know about the technologies. So so for us, it's but of course we are also interested into the polymers. You've seen we use all kinds of polymers. So we have a brilliant let's say, materials like APL and EP and whatever. But let's say, we're learning ourselves on that aspect a lot. I know I'm in contact also with SABIC, thanks to EPIC again. And so we have a lot of ideas of doing that, but it's a little bit too detailed to show that here.
Of course, we understand that. Let me see if I have first a question for you. Please raise your hand if you have a question to UPMT. Otherwise, let me go to the, thank you so much again, Marc, for this very nice, I think Miguel, you wanted to ask something? Was it hello? Oh yeah, please unmute yourself and say hi. Tell us what you do.
Hi. Well, that's I wasn't willing to ask any question, but as you give me the opportunity to speak, just say hello to everybody. And yeah, we are working on elastomeric optical fibers, and this is a project we started already almost 1 year ago. And the key problem we've had by introducing polymers for research is the availability of the materials. It's a very, very, very difficult for us to get the right materials, not because they do not exist, but very often because a lot of companies, they just want to sell huge amounts of materials. For example, we are working with TPUs, which is a thermoplastic polyurethane. And we've had several contacts in different companies. And one company just said, okay, yes, we can provide you some TPU, but the starting amount for selling is 30 tons, whilst we just need a few kilograms. So yeah, this is, polymers is very interesting, very big opportunities for making new components, but the availability of the materials is very often very difficult.
Would you like to say something about that, Marc?
No, not particularly. I wanted just to mention, because you asked me about, let's say, the needs to other partners. So yeah, I think we will need stronger partnerships in time to bring our technologies to industrialization and scaling up. That's for sure. That's for sure. But I think the first step is always to prove all the possibilities of the technology on a smaller scale, but then scaling up for a small company like ours is a very big trick. It's not easy.
Absolutely, but it's good that you are part of Fabulous, the European pilot line for free-form micro-optics manufacturing. And this is one of the goals as well of this pilot line. To know more, so I don't want to consume the time of the meeting speaking about Fabulous only, but to know more about Fabulous, I put the link to the website and you can reach out to me and I can give you all the information on how to reach out to companies like UPMT that are partners of Fabulous and how to reach out to the pilot line. The goal is to...
We may have some sound problems with Sana. I think it's okay, but she was saying that the goal is to enable pilot production. So what we are saying here is that there is money from the European Commission to access the technology of SUS micro-optics or UPMT, Wielandts. I think we have your sound back, Sana.
Oh, great. Thank you. Yes, I was saying that we want to centralize this free-form micro-optics manufacturing. And when you want to go toward this, we have 6 end users, including from the automotive industry. So please let me know how we can put you in contact with this pilot line. So let me see if you don't have more questions, then I am very, very happy to be moving to the next talk from Vadient. It's so nice to have you here. Thank you so much for joining this online technology meeting. James, please unmute. I'm so looking forward to your talk, James.
Thank you. Good morning from Oregon, but good afternoon to all of you. I'd like to thank EPIC for inviting me today. I'm going to talk a little bit about freeform gradient index optics. My name is Jim Field. You can see my email below, but we're in Oregon. Which is probably not known for optics, but we are known for printing. We've created a process of optically engineered feedstocks using nanoparticles and high and low index inks to inkjet print gradient index optics that allow us to tune and sculpture the light through the optics versus sculpturing it using the surface of the optics. We've created a whole process so we can design using plug-in tools for ZMAX and Code 5. We can do both on-axis and off-axis in free-form gradients of the optics itself. And we've created a suite of metrology tools within the company. There are 25 of us, so we're probably the smallest to present here today, just like Marc, but we've created a process to create these optics. What does GRIN do for you, and what does the sculpting of the light allow you to do? It allows you to get optical power without using surface features for those. It allows you to correct for geometric aberrations and chromatic aberrations using the differentials in the materials and the concentration of the nanocomposites that we use to create GRIN. It allows optical designers added degrees of freedom to improve the optical performance and also reduce the lens count by combining two lenses into one. We can use inkjet printing to create aperture stops, fiducial marks, also alignment features within the optics. Again, it's a full process. We can go from design to creating the on-demand inks that we need for your optics, loading an inkjet printer. We have high-level diffusion masks that allow us to get good concentrations and quality of the optics we make, and we can print both 3D and freeform GRIN optics. The increased freedom for the optical designers allow you to use larger order cross terms like R and Z, reduce optical aberrations like coma, tilt, and spherical aberrations. So it gives you, again, some design freedom that you haven't had with traditional optics. You can see us correcting here for some chromatic aberrations using both the nanocomposite materials and the inks themselves in the high and low index to do those corrections. So we can create very interesting optics using this capability. Today, we can produce 125 millimeter optics per hour on inkjet systems. What this allows us to do is leverage the billions of dollars that have been spent for inkjet heads and inkjet systems in the world. Our system has 6 channels, so 6 optical inks can be fed simultaneously. We do droplet monitoring, and we have process control to control our gradients and ensure that we have both the right high and low index gradients as we print, and also to verify that the optics that we're printing in that gradient are correct. These are just some of the examples that you'll see that we've printed. We started the company in 2013. There are 25 of us working. We have chemists on staff, which isn't totally normal for an optics company, optical designers, and we have people who are alumni from Hewlett-Packard's print division that are part of our staff. So that's why you're seeing the quality that you see here, a variety of lens arrays, a phase corrector plate that you'll see here. Also able to print directly on chip scale packaging. This is an application that is starting to gain some traction with us. Also, we've created flat Alvarez lenses. We can print baffles in your optics so that stray light doesn't interfere with the other optical channels. We've developed Fresnel barrel lenses, and again, a lot of planar optical arrays are part of their portfolio. One of the things we're proudest of is our ability to create free-form gradient patterns. This is a grin lens that is a phase corrector plate for optical mirrors. So we can print this by just getting the Zernike polynomials from you on the corrections that need to be made in the phase corrector. Print this, and you can put it in between the mirror and the imaging device to do that phase correction. Our print volume is such that we can print optics as large as 1 meter by 1 meter, but we've also printed very small micro optics down to about 160 microns. And the obvious questions is, what can you do for us and what can we do for you? On our side, if you want to entertain a grin optics design and you haven't used grin before, please get in touch with us. We can turn around optics very quickly. So from a design standpoint, you can try different avenues to see what works and what doesn't. And again, we're a young company, and so we're always looking at new features to improve ourselves, like high index polymers. We're looking for partners for that, and I've already spoken to numerous guys who are on the dais today. We're looking for high volume inkjet printers because 100 parts per hour is nice, but what our customers would like is thousands of parts per hour. And then distribution and service bureau. We are going to be opening up service bureaus around the country to do this kind of printing, and we'd love to have discussions with that. And with that, thank you very much. And
thank you very much, James. Fantastic. And look, 5:30, we always finish on time. Your epic question is very, very clearly answered. And I think one of your future customers is the person who I want to give the floor to. We have a question from Wave Optics. Arseny, tell me.
Awesome. Just a couple of technical questions. So in terms of your gradients and refractive index, what kind of refractive index you are using right now with those polymers? And in terms of gradients, what kind of spatial control of those gradients you can achieve?
So we have the low index inks, we go down to right around 1.1. High index inks, we're in the 1.6. We're looking at going a little bit higher, and we have some developments in that area. And then we have very good spatial control. So they're micron droplets, but with nanoparticles in there. So we control them spatially very well. And part of that is the chemistry we use, so that we control where those nanoparticles and the concentration of those nanoparticles through ligand chemistry. Some of the ligand chemistry is to keep the nanoparticles separated at a distance, and part of the ligand chemistry is to embed them in the monomer so that they don't move as we print.
Green Optics has fantastic optics. I think there is obviously a room for cooperation here. The presentation was extremely clear. I think I'm going to go now to give the final remarks. And I decided to choose for every meeting a person to give the final remarks. For this one, Andreas from IMTech, you have the chance to sending us off the way that Epic loves it. Tell us, what kind of cooperations, what kind of future we have for IMTech cooperating with the members today?
Thanks, Jorge. Thanks for this honor to give the final remarks. Yeah, I did already send some private messages to some people here, to some companies who are, potential customers from us, and maybe customers who we can support. Amtech Graphic basically is the market leader in diamond turning machine tools. So this is what we do. So whenever you have an in-house optics production, and that could mean that that diamond turning is a way to do this, and I'd like to support. So that's all I want to say. So diamond turning, this is what we do, and optics manufacturing, and some of you may know us already. Some of you are customers from us, and maybe I can start discussions with many other
I hope you do. And you know, I also have something to say, which is that I learned a lot of this meeting, and basically I see three main challenges for this community. The first one, Wave Optics told us they are looking for for molded optics with refractive index of higher 1.7. Let's find that for them. Volvo, you were the star. Paul, you were the star of today. They told us about more sustainable material for recycling, less coating. They want to get rid of metallization, better transmittance, reflectivity, homogeneity, weight reduction. I highlighted that. We need to address that. And Khatod, first ever EPIC meeting, manufacturing process. The world loves it. I want to visit. We're going to go there soon to visit you. And you were looking for a PMMA-like polymer. It doesn't exist. We know the physics. PMMA-like polymer for transparency at 250 nanometers. Let's address those challenges. There are lots of business opportunities. It's 5:34, 4 minutes late. I'm very sorry, but it was another epic meeting. On Wednesday, a specialty optical fiber. Until then, keep being epic. See you soon. Bye-bye.
See you, everybody. Thank you so much.
Bye.
Bye-bye.